Hi, we're going to talk about reading another type of file. In this video, we're going to focus on a different kind of flat file called a tab separated values file or tab delimited file. All right, so what is a flat file, first of all? A flat file is a way of storing data in a rectangular format and where we have rows and columns of data. Okay, so one way to store data in that way is that we'll store it into a file on the computer, and we're going to use a comma to separate the different values so the computer knows when we have two different values. That's a comma separated values file. Or we can go where we have a tab that, between data, and that will signal that we have different values to the computer. So that's a tab delimited or tab separated values file. All right, so let's go ahead and take a look. I've got some code in Python to take a look. All right, so remember now, in Spider, I press F9 to run a line, and if I have the hash marks, that means that the computer doesn't recognize this. It doesn't execute it. It just prints it and nothing happens. I put it in here so that you can look at it, you can read it, you can better understand what I'm doing. So first and foremost, I'm going to set my working directory to where I want it. And this is just good practice if we have that luxury. Now we're going to use pandas to read the file in. So I need to import pandas, and I abbreviate it as PD. Now you notice I have all of this highlighted. I press F9. All right, so now the iris data set is in my working system. Okay, so what we've got going on. Let's go ahead and let's take a look at some summary statistics. Well, for almost everything mathematical in Python, we want the Numpy or a related suite of functions to work for us. So let's go ahead and import the Numpy package. All right, and I'm going to abbreviate it as NP. Now, Numpy likes to have data frames. So what I'm going to do, I'm going to take from the pandas library, remember I abbreviated PD previously, I'm going to take the data frame function and I'm going to apply it to the iris data set that I just loaded in. All right, so let's do that. All right, so now the DF is a data frame containing the iris data set. All right, well, let's get some summary statistics to give us a better feel for what's in this data. So let's take the count. All right, so we know that we have 150 observations for each of the variables. So we have septal length, septal width, petal length, petal width, and species. All right, well, so this is a data set regarding flowers, and there's 3 different types of species, and these are all features that were measured in this. This is a classic data set. This is used in every data class on the planet. All right, now let's look at sum. All right, so if I take out if I add up all the measurements for the first 4, we can see we get 800 something, 400 something, 500 something, you know, a little bit less than 200. And then we go, whoa, 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 whoa. The sum function takes character strings and it tacks them all together, concatenates them, and makes it into, you know, it just it pastes them together, and that's what we get. That's useful if you need to combine some, like, let's say some names together, like you could do the sum of, you know, first name space last name, and that will give someone's name that way. All right, well, let's see what happens when we hit mean. So I'm at the mean. All right, so I get the average of each of these. Now, it doesn't make sense to take the average of a character string, so nothing happens. Let's look at the median. Okay, now, something that's interesting in statistics, when the mean and the median are far apart from each other, that's a good sign that you have skewed data. We'll talk about skewed data later in the semester. Now the mode is most frequent observation. So we can see that the most frequent observation for length is 5, for septal width is 3. Now here we have 2 different ones. That's because 1.4 and 1.5 occur equally frequently. So they're like tied for the top, and then 0.2, and each of these appear equally frequently. Therefore, each of them is a mode of the data. All right, so now let's get the standard deviation. Let's get the max. Now here, when we take a max or a min on a character string, the minimum is what's alphabetically first, and the max is what's alphabetically last. So here, S, when we did the min, we get S, and then when we go max, we get the V. So alphabetically, max comes afterwards. And so here are the levels that we have. We can see alphabetically, the ones, Setosa is the first one, and Virginica is the last one alphabetically, and the minimum and maximum functions pulled exactly those. Now, let's take the product. So it just multiplies all the entries. This isn't useful in very many situations. Now you'll notice I went through, I pulled each of these individually. Let's say if I just want like a quick, fast, get all of the ones that are usually the most useful, at one time I can use the describe function. So dataframe.describe, and what it does, it gives me the count, the mean, the standard deviation, the minimum, the maximum, and the quartiles. Spits them out for me. Well, that's pretty nice. And then in addition, we have the ones that we used previously in the video for the comma separated values. I kept these in here in case you want to take a look, dig a little bit deeper. All right, well, that's all I got. I hope you're doing well. Take care.